Done with this question? Were you able to just multiply, right? We just do the multiplication. We multiply the first one by 2. All right. And then we multiply the next one by 3. And then we write all our answers. So what are we going to have? 2Cr plus 6 hydrogen ions to give us what? 2Cr3 plus what? Now check this here. Guys, I am multiplying this by 3. Is that okay? All right. So what am I going to have here? 3H2. Is that what you have? Yes, if they are all even numbers. But this time around, the 3 will not allow me to divide. Yay! I can see Appa dancing there. Appa is dancing. All right, awesome. So we're good. Okay, let's move on. I want to go to electrolytic. How will the reading on the voltmeter change? All right, guys. When there is an increase of M3 plus ions, when there is an increase of M3 plus ions, which one is our M3 plus? It is the anode. All right. Give me your answer. I just explained this a while ago. It will decrease. Thank you. She looks like an electrocuted worm. Oh my God. Oh God. It will decrease, right? It will decrease because the concentration will increase. I did explain all of that in details when I was explaining, so we can move on. Write down the reading on the voltmeter when the reaction has reached equilibrium. What's your answer there? When it has reached equilibrium, what is your answer? Guys, I'm trying to move. Please, I need your response. I need all your responses. Thank you. 0 volts. Name 2 potential hazards associated with the use of the hydrogen half cell. Potential hazard. All right. Number 1, hydrogen is an explosive. Hydrogen is an explosive. So you could go kaboom. Remember, hydrogen, it will go boom. Yes. All right. What's the second one? I'll think of the second one right now. All right, so the first one coming to my head right now is that it is hydrogen is flammable, all right, because it's used as fuel. Okay, I would remember the second one as well. Because it's hydrogen, I'll remember. It's not coming to my head at the moment. It's a very, very unique question that they're asking here. But I'll give you an answer as we go on. All right. I hope we are okay. I'll give you an answer as we go on. Hydrogen is used as fuel. All right. Your rockets and all of that use hydrogen. Your rockets, your airplanes and all of that use hydrogen. So it is very, very explosive. It can be used as a bomb. Make you hot like a heater. All right, guys, that is galvanic. I hope it makes sense now. Look, electrolytic is more of a different energy conversion, but the process would remain similar. All right. So let me give you a crash course on electrolytic. A very quick crash course on electrolytic. All right. Electrolytic. Then at least I know that we have covered this. The remaining is acid and base, which we have done. It's only the calculations that can be challenging. So we're spending more time on our electrolytic cell. The first thing I know here is this: electrical energy is converted to chemical energy. And what type of electrical energy do we use? We use a DC to maintain polarity. All right, there are 3 steps here involved. 3 steps of electrolysis. If you have the song again, it is all stated there. Number 1, separation or breaking down. Let's use, since I've been using breaking down for those of you that were here. Breaking down of electrolytes. It breaks down. All right, it separates. It ionizes. Of electrolytes. The breaking down of your electrolyte. Number 2, this is where I'm going to answer your question. Number 2, migration. The cations would move to the cathode and the anions move to the anode. Number 3, redox. Okay. So I'm just going to answer questions here and use them to guide you. When there is a power source, automatically it becomes, you are switching it now. When there's a power source, it is an electrolytic cell. Sophie. When there is a power source, it is not a galvanic. A galvanic produces. A galvanic is a power source. Let me know, child. A galvanic is a power source. All right. Let's use this to answer our questions. It's very straightforward. A metallic object is to be plated with copper. Now, please listen. Anything you want to electroplate, make it the cathode. Anything to be electroplated. Anything to be electroplated is the cathode. Anything to be electroplated is the cathode. Please take note of that. So this time around, which one is my cathode? That becomes my cathode. And this is my anode. So identify which electrode will be the anode. We all know now it's copper. Okay. Whatever is to be electroplated is always the cathode. Don't forget. Identify the terminal to which the object must be connected. This is an electrolytic cell. Anode is positive. All right, thank you. Anode is positive. So this is the positive end, and that's the negative. I'm sure we've answered 7.2. Identify the terminal to which the object must be connected. It is the negative, because it is the cathode. The anode is positive here. State whether the copper ions are oxidized or reduced. Guys, what's your answer here? Let me check something with you. Are copper ions oxidized or reduced? Uncle Echo, copper ions are not oxidized. Ions are reduced. Do you remember the lesson we had when we're talking about ghosts? Uncle, do you remember the ghost lesson? Huh? This child doesn't remember ghost. Oxygen will take place at the anode. Thank you, Duduzi. Duduzi is finishing you here. Okay. I see, guys. Even Loniel. Most of you that are confused are okay. Let me help you here. Yeah, I remember she even told me to stop when I was saying no. No, I remember that night. She was telling me, no, stop, sir, stop, sir. Now she's telling us she doesn't remember. All right. Guys, listen. Oxidation takes place at the anode. It doesn't mean that the anode, that electrode, please listen. Let me try to break this down. Oxidation occurs at that electrode. Wait, what is oxidation? Let's go back. What is oxidation? So that we don't get confused. It is the loss of what? Electron. Check this. If you say copper ions are oxidized, look at what I have. That is the half cell for copper. This is copper solid. And this is copper ions. Wait. Zanele said something very important. Now, I'm taking this from the formula page. What does plus mean to you? Gain. Gain what? What is the gain of electrons? What is the gain of electrons? Reduction. So do you see that copper ions are reduced to copper? Please take note. And I said you cannot reduce a solid. Remember? You cannot reduce a solid. And ions can be reduced. Solids cannot be reduced. Ions can be reduced. Leave Nonku alone lying to me here. I'll go and bring the register of that class. All right, so even if I write it backwards now, at the anode, check what I'm going to have. Copper. Do you see this? Now, at the anode, what happens? Oxidation. Do you see that copper solid is oxidized to copper 2+? Just use your half reactions, guys. Nonku, use your half reactions. Look at the half reaction. I'm going to write the half reaction again. This is what you have. Copper 2+ plus 2E. This is the original one. So if it is the anode, what are we going to have? We start from the right. What does that tell you? Copper solid is oxidized to Cu2+. What will I have at the cathode? Cu2+ plus 2E to give us what? Copper. What happens? Copper ions are what? Reduced to copper. This is me using the half reaction. So if I want to electroplate, for example, let me explain this whole question to you. All right? But this is me using the half reaction. So this is what the examiner has done. Let me get a beaker. You know, I always like to use fancy things. Let me go buy one beaker quickly. There we go. All right. I have a beaker that I've bought here. Okay, the color, liquid color should be blue because copper is blue. So what I have here is copper sulfate. So this is the whole process. So please follow through. This is the whole process of electrolysis, and basically we are looking at electroplating. So I want to electroplate with copper. Therefore, I will use a copper solid electrode. And whatever I want to electroplate, I'm going to put it here. So I want to electroplate a ring. Okay? Remember, this has to be copper now. And that is my ring to be electroplated. Whatever we want to electroplate should be the cathode. All right. So, step 1. Let's check. Step 1. Do you guys remember step 1? The electrolyte would break down. Copper sulfate would break down into Cu2 plus SO4 2 minus. Okay. So what are we going to have? We are going to have Cu2 plus SO4 2 minus. Step 1. This is the whole process. Step 2. Migration. Remember that this electrode is negatively charged. This one is positively charged, right? Unlike charges will attract. So Cu2 plus will be attracted to that. Does that make sense? SO4 2 minus will be attracted to that. That is step number 2. Step number 3, redox. Now, this is the question the examiner is asking. What happens at the anode? Oxidation. Copper ions will not, since guys, we said it's oxidation, right? We write it from the right, going to the left. Do you see? We write it from the right, going to the left. What is this? Copper solid is going to be oxidized to copper 2 plus. Just use your half reaction. Copper solid from the right to the left, remember? Copper 2 plus what? 2E. What happens at the cathode? We have copper 2 plus going to the cathode. It will be reduced. We write from the left to the right. Please tell me now if you are okay, because I have simply explained the whole situation. That's the whole process. Still confused?
Sir,
Yes.
I'm okay. Guys, he said reduction occurs within the anode. Go back to the question.
Reduction occurs at the anode. Jesus, me. Never. I have witnesses in this class. Okay. We are here. Danko. Turn this way. Step 1. Electrolytes would break down into plus and minus. Done. Your electrolytes will break down into cations, and that is electrolysis. That is what you define as electrolysis. The conversion of electrical energy to a chemical change. So that is step 1 in all the cells. So please note, state whether copper ions are oxidized or reduced. Copper ions are reduced. Copper is oxidized. Guys, everything will be answered through your half cell. Is that okay? Your half cell reactions will tell you everything. Copper solid is oxidized to copper. copper ions are reduced. And by the way, let me quickly answer something here. What happens to the concentration here? The copper sulfate concentration will remain what? Constant. Why will it remain constant? Guys, we are losing this copper 2 plus here. It's forming solid. Right? But this one here is going back into the solution as Cu2 plus. So whatever is lost is gained. We lose this one, it becomes that. But this one goes back into the solution to replace what is lost. Hence, this one will decrease in size. While this one will what? Increase. I hope you're good now. That is the whole process. Nonku, you're welcome. I'm glad that we got it. All right. Let's see. Okay. Write down the half reaction that occurs at the cathode. We've done that already, right? We did that. Explain why the power supply must be a DC. I did explain that. To maintain polarity so that the anode remains the anode and the cathode remains the cathode. To maintain polarity, the anode must remain as the anode and the cathode must remain as the cathode. If it is an AC, then we are going to be changing all the time. At a point, one will be the anode. At the other half, it will be the cathode. Please let me know if that's okay. Let me fetch Nonku's question quickly, and we can look at that as our second question. Nonku, again, what paper was it? (2014) Free State. Tutuzi, if I use an AC, it's going to be alternating, right? The anode will become the cathode and then be the anode again, electrodynamics. But if it's a DC, that terminal is positive throughout. That's what we mean by maintain polarity. The anode will remain the anode. Let me demonstrate something for you. Probably it will help. I wish I could demonstrate it live, but let's try if I can demonstrate it here for you. So, I have this. I have an AC. This is supposed to be galvanic. Anode is positive. Cathode. All right. Check here. I am supposed to lose electrons. Electrons are supposed to go that way. Is that okay? Because electrons will go from the anode to the cathode. Electrons are negatively charged, remember? This is the positive end of the battery. That's why electrons would go towards the positive, right? Good. And electrons are repelled. Do you see that's negative? There's a repulsion. It goes there. That's where we talk about the gain of electrons. All right, this is the setup. So this is half the cycle. By the time I go to the second half, what happens? This guy then becomes negative and this guy becomes positive. Oh, the electron that was coming. I don't know if you get that. The electron was going because it sees a boyfriend there. When it gets to this last junction to turn right, the boy becomes a girl. Ah, no, I don't do girls. Come back again. By the time it's going back to, but I was playing with you. Come now, I'm a boy. It goes again. When it turns to the left, I'm a girl. Comes back again. Do you see that? Sophie's always laughing. I don't know why. But don't write boy, girl in the exam. Okay? All right. Aww. You'd never forget this lesson. That's the whole idea. That's why we call it crazy face. I'm actually dancing. Do, 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 bum, 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 bum. Nonkel Echo, you write boy and girl. Well done. I don't know you. All right. So it maintains polarity. Is that okay? It maintains polarity. It maintains polarity, or to maintain polarity. To maintain polarity. The anode remains the anode as electrons are lost and gained at the cathode. AC power will change the polarity of the electrodes at every half cycle. I hope that is a very detailed answer for you now. Yo? Hey, I'm dead. Then write Mr. Bishop as a reference. Oh, nobody knows me, people. They don't know me. Okay, let's answer Nonku's question. And I think we should be done with that. All right. And then you can practice more. Nonku's question. Nonku asked me a 2014. Let's go check. I hope I have. 2014 Free State. Past papers, 2014 prelims, Free State. Yay! I got it. Do 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 do. I got this. Do 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 do. Boom 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 boom. I got this. Yes. Hashtag crazy physics. All right, Nonku, I hope it will be the same question. It's the one, right? Yes. All right. Fat Rap. I see you listen to a lot of songs. MC Hammer. Do 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 do. Can't touch this. Do 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 do. Can't touch this. All right, let's answer this. We're going to do this very fast and then we'll be done with electro. I'll just tell you the other processes. Okay. Yo, where did I learn? Drew, I've seen a few Christmases, hey? The simplified diagram below represents an electrochemical cell used for the electrolysis of concentrated. Now, please listen. They say concentrated sodium chloride. All right, Nonko, I'll share the memo with you. Concentrated sodium chloride. Okay. Now, look at the word. The word solution tells you something. It's actually good. I love this question. Thank you, my child, for bringing this question. This is called the electrolysis of sodium chloride. All right. But here is my first call of attention. The word solution means there is water. All right. So there is concentrated sodium chloride and there is water. I hope it makes sense. Although it's concentrated, it still has water. Unamanzi. Am I right? I know some people are laughing right now. Unamanzi. Is it galvanic or electrolytic? I know that child will be the first one to laugh. I'm wrong. Sophie, am I wrong? It's electrolytic, thank you. Am I wrong when I say unamans? Une amans. What am I supposed to say? Kuna man, it's just the K. No, I took the K and put it on crazy physics. That's why I said Kuna man's. The K's were crazy physics. Yin. All right. Okay. But at least I'm trying. All right. Electrolytic. Now, let me quickly explain the process here to you. Please, everybody listen. It takes me 5 minutes or less than. So, what is our do you remember the 3 steps? Step 1, sodium chloride would break down into Na plus and Cl minus. That's our step 1 repeated. What is our step 2? Migration. Okay, let's go check. Migration. By the way, in this cell, we use carbon as our electrode. You will see they would say carbon or graphite. In both of them, carbon. All right. Now, we don't know which one is positive or negative at the moment. Oh, let me do this. Let me go to a fresh page and explain this, because I see that the examiner has something in mind about positive and negative. So let me do mine. Okay, and then we'll answer that question later. So here we go. If I connect this to negative and connect that to positive, remember what I have? I have Na plus and Cl minus, and I have water. I hope it's okay now. All right, so my step 1 I have already done. What is my step 2? This one is positive, this one is negative. All right, my step 2 is that the positive one comes towards the negative, and the negative, positive, negative, positive. All right, then positive, negative, positive, negative. Is that okay? Now, step 3 is redox. Do you see, guys? It is the same 3 steps. Now, what happens at the anode? Don't forget ape. Anode is positive. That's my anode. And this is my cathode. And remember, we are using carbon as our electrodes. So what happens at the anode? Oxidation. Let's go to our table. Remember what we have here. Cl minus attracted towards the positive because opposite charges will attract. But what happens? Oxidation. Just go to your table, guys. Let's go to our table and look for chlorine. Please find it. It is very close to the bottom. It's number 5 from the bottom. It's number 5 from the bottom. Number 5 from the bottom. Have you found it? Thank you, Mduduzi. I love it when you respond to me. Everybody tell me you found it. Everybody. Anneli, did I pronounce it well? Everybody. Everybody. All right. So remember, it is oxidation. We're starting from the right to the left. Good. Anneli, yeah, she's back. Anneli is back. We start from the right to the left. I hope it would make sense now if I tell you that. Where is it? So if we are starting from the right to the left, can I then tell you that we are going to have 2Cl minus, Cl2 plus 2E. They even told you it's a gas. So we are saying chloride ions are they oxidized or reduced? Talk to me. They are what? At the anode. Sophie. We are at the anode. Sophie, she's gone quiet on me. Sophie. They are oxidized. Don't forget, Sophie, anode oxidation. Okay. And ox. So chloride ions are oxidized to form chlorine gas. There's a bubble there. Bubbles. That's how we know gases are formed. The next question is, guys, what happens at the cathode? All right? What happens? She's laughing. What happens at the cathode? Red cat reduction. Now, please take note here. This is the little trick. What will be reduced? Thank you so much, guys, for giving me those answers. Somebody's thinking sodium will be reduced. But hold on. I have sodium. I have water in this solution. One of them would be reduced. All right? Let's go back to our table. Please find water and sodium for me. Water and sodium, natrium. Let me speak some science now. Water and natrium. EP table, yeah. Okay. That's it. Water and natrium. Check my natrium here, which is my sodium. And check my water. Guys, the water is this one just below sodium. Please, I want you to listen to this, as I don't want you to get confused. All right. Okay. Hello? All right, we're here. So, one of them would be reduced. If I compare these two, which one should be oxidized and which one should be reduced? If I compare sodium, just comparing sodium and water, which one should be reduced? Just comparing sodium and water. Nonkuleko, you were saying something? Good. Water will be reduced. And look at what it's reduced to. Hydrogen gas and hydroxide ions. Hydrogen gas and hydroxide what? Ions. I'm just going to go write that there. So water is reduced. It's 2H2O plus 2E reduced to what? Hydrogen gas. The question is, why is it reduced? Water is reduced. This is a common question, and it will be there in your next paper. Water is reduced because it is a strong oxidizing agent. Then, not sodium, sodium ions. It is a stronger oxidizing agent than sodium ions. Loniel, did you get it now? Because I see you said, oh. I just saw your message now. You got it? All right. So at the end of the day, what are we producing? We are producing hydrogen gas, which is also given out by bubbles. Now finally, what do you have left in the solution? Sodium ions is still there. We also produce hydroxide ions when water was reduced. Oh, so what are we going to form? Sodium hydroxide. That's why this electrolysis is very, very important. Normally we use what you call a membrane cell. All right? Not cell membrane, please. Cell membrane is life science. a membrane cell. Please let me know if we are okay. It's such a beautiful process, Nokuleko. Such a beautiful, beautiful process. It is still the three process. All you need to do is to use your table. No, oxidized and reducing agents are not the same. Oxidizing agent, oh, you said is oxidized and reducing agent. Yes. Remember the table I showed you. Whatever is a reducing agent is oxidized. All right. Loniel, sir, is this the industry thing? Yeah, this is called the chloroalkali industry. Chloroalkali. Why chloroalkali? Alkali is a base. So we are forming a base. Three things are formed here. Sodium hydroxide, hydrogen gas, and chlorine gas. And all of these are used every day. Chlorine is used for water purification. I'm sure you all drank water today. Sodium hydroxide is used for soap. I'm sure you all had your bath today. Hydrogen gas. I wrote H squared. My God. H squared. Jesus Christ is Lord. It's H2 here. All right. Hydrogen gas, we spoke earlier on, is used in your organic chemistry. All right. For hydrogenation. That's how margarine is made. Your margarine, your rama, and all of those. Made from hydrogen gas. And number two, your rocket fuels. It serves as energy for rockets. Remember we spoke about the hazards of hydrogen gas. Okay. Yes. Yes, my child. On one side, chlorine gas. On the other side, hydrogen gas. Okay, so let's answer these questions now. Very easy now. All right, chlorine is released at electrode Q. I'm going to show you something here. Chlorine is released. I really cannot say. There are 4 possible options. But the 4 options have the same process. That's the thing. All right, guys. They said chlorine gas is released at Q. Watch that statement. By the way, I keep writing this. Chlorine gas is released here. Wait. Is chlorine a positive ion or a negative ion? It's a negative ion. All right. It is a negative. What does that make Q? Is Q positive or negative? Talk to me now. Q is positive. Do you see the game I'm playing? Very lovely game. Q is positive. P must be negative. And ape, the anode is positive. Guys, we are done here. So, let's answer 9.2.1 to 9.2.4. Electrode P or Q. Write down where reduction takes place. Is it P or Q? Where will reduction take place? Reduction takes place at the cathode, and that is P. You see, we're done. Half reaction that takes place at P, that's the one of water. Don't forget, it is the one of water. All right. So we write that half reaction for water. That's what is reduced. Okay. Are we okay, everybody? I've explained the whole process. We're just answering now. Direction P to Q or Q to P to which electrons flow. Electrons would flow from the anode to the cathode. Nonkuleko? Does that make sense? Anode to the cathode. It's Q to P. Thank you. Name of the species that act as reducing agent. A reducing agent is oxidized. Let's go to our half reaction. Which one is oxidized? Chloride ions. I'm done. Do you see, guys? Chloride ions are oxidized. So everything starts from your half reaction. Write down the balanced cell reaction that takes place. I'm sure we can do that now, guys. Balanced cell. It was Cl2 to give us what? No. It was 2Cl minus, what we wrote down earlier on. So you need to write this down. And then we have 2 moles of water plus 2E to give us what? Hydrogen gas plus OH minus. And the beautiful thing is your electrons are already balanced. So what do you have? 2Cl minus plus 2 moles of water to give us hydrogen gas. Good. And that's it. You need to, when they say the agent, you need to write out, if they say reducing agent, then you need to go check what is oxidized. Use your half reactions to always answer that question. Okay? Use your half reactions to always answer the question. All right, guys, I have done electroplating. I have done sodium chloride. The same process would happen with electro refining, okay? Purification of metals. The same process. Yes? Oh, sorry, it's a mistake. Don't shoot me, Mduduzi. Oh, why? Relax. Rest, Papa. Rest. It was a mistake, Mdu. Okay. All right, guys, I hope you're okay. What you need to do, just look for a question on electro refining. Or even if you read it now, it will make a lot of sense. Even if you were to read it now, it should make a lot of sense when we talk about electro refining. Okay. And this question, I'm not going to do this question. You can try it on your own. Okay. You can try it on your own now. Okay. Electro refining will be there. Well, if it's there, not a problem. We've answered this one, guys. Do you see again here? Hydrogen gas, we bring in platinum. There's a question I see here, guys. 8.6.3. Is this going to be exothermic or endo? The answer is exothermic. Okay? Galvanic cells are exothermic because it is spontaneous. All right. Let's answer this question. Guys, this one I'm not doing a crash course. We're just answering the question. All right. This is chemical equilibrium. Let's just answer the question straight. Because I know the main challenge is the 7 marks. But guys, electrochemistry, are you okay now? Did we cover what are you happy? Let me say that. Are you happy so far? Very happy. Yay, Loniel is dancing. Oh, what a smile from the uppers. Umdu is confident. Referring to yes, sir. Get yes, sir, yes, sir. Madi say yes, sir. Zanele, yes. Tunisani, yebo. I saw Dunisani today for the first time, guys. I was in his school. Dunisani is so quiet. For the first time, I saw him today. He's so quiet. He's an angel. Yo, like you, Anele. Yes, yes. Dunisani that you see on the group here, he's a different boy at school. Like, yo, I wish I was that quiet. Yo, Kaylee says me also. Guys, you need to see Kaylee at school. Come on, like really, everybody knows Anele and Nonkuleko are not quiet. Oh, but in. Okay, I will. Kaylee, you are not quiet. Please stop lying to us. We know you. We knows you. We knows you. All right, guys. Duduzi says, may we do question 7 from September 20. All right, Duduzi, when you say September 2017, which province are you referring to? I'm sorry, what do you say? I'm so sorry. I'll come to your school someday. Duduzi, you said 2017. You need to tell us. Dunisani, quietness comes with books. I'm talkative in soccer. I see. All right, let's answer this question while I'm waiting for Duduzi to give me the year. He's requesting us to do a particular paper. Kelly, please stop saying you are quiet. You are not. If I check the dictionary definition of noisemakers, I'll find your face. All right, guys, let's look at this. Chemical equilibrium. The equation below represents a hypothetical reaction that takes place in a closed container at 350. Please understand, chemical equilibrium can only take place in a closed container because the reaction must be isolated. All right. The letters X, Y, Z represent the number of moles in a balanced equation. All right, so we have all of this here. The graph below shows the moles of reactant and product versus time during the reaction. So we have all of this stories here. A, B, C. All right, A and B are the reactants, and product. Look, what I'm quickly going to tell you is this. Look at the dynamics here. Look at A. A starts from 4 and ends at 3. I hope you see what I'm trying to say. A starts from 4. Initial was 4. Final is 3. Since it's a reactant, it means we have used 1 mole of A. 1 mole of A. Plus, in case I lost you there, let's do B together. All right, in case I lost you, look at B. B starts from 3 and ends here. Remember that line means equilibrium. And what is that value? That value would be 2,5, right? From 3 to 2,5, we have used 0,5, which is half B. And look at C. C starts from 0 and ends at 1, which means we have produced 1 mole of C. In chemistry, we don't balance with halves. So what we do is we multiply across by 2. 2 moles of A will react with 1 mole of B to produce 2 moles of C. All right. Do the KZN. KZN, what year again? I can't message. KZN what? Prelim trial 2021. Okay, 2017 KZN. All right. I'll do that when we answer this question. Guys, are you okay with my interpretation? Let's get this 16 marks like chop chop. Let's get it like nothing happened, you know? All right. Define a reversible reaction. A reaction that can go forward and reverse. I hope that's fine. A reaction that can go forward and reverse. After how many minutes did the system reach equilibrium for the first time? Give me an answer. For the first time. After how many minutes? Awesome. 1. Use the information to write down X, Y, and Z. I have done that. X is 2, Y is 1, and C is 2. X is 2, Y is 1, and Z is 2. Can I get a thumbs up if you're okay? Can I get an okay if you're okay? Can I get a yes if you're okay? Can I get a yebo if you're okay? Yes?
How do you get the half D, 1A,
No, Kuleko, were you in class when I was explaining that? So when I was doing all of this, what were you hearing? And then she laughs. I did, and I'm asking you a question now. Where were you when I was explaining all of that? This child, I don't understand this child. A, 4 to 3. It's reducing. We start by 4, we finish at 3. What did we use? 1 more. That's your 1. B, we start at 3, we get to 2,5. The difference is half. That's your half. C, we start from 0, we get to 1. That's your 1. But I cannot leave them as fractions. Oh, you see it now. Okay, so we multiply by 2. All right, everybody, calculate the equilibrium constant for the reaction C, for the reaction at 350 degrees Celsius if the volume of the container is 4 dm cube. 7 marks. Calculate. I want to give you 4 minutes. Let's make it 5. Calculate. Remember the volume? Volume is given as what? 4 dm cube. Please calculate Kc. It's 7 marks. I'll give you 4 minutes. 4 minutes should be fine. It's not so much. 0.18. Are you sure, people? Oh, 0.18. Loniel. Loniel also got 0.18. All right. Okay, let's mark. I see a lot of requests coming in. There's 17 Free State. Question 7.1. There's 2017 KZN. Okay. Not a problem. You guys said you got 0.18. Is there somebody who is not getting 0.18? I don't know if that's the answer, but I see a lot of us getting that. Okay. I see some no's. Now, guys, the easiest thing is to use your table. Okay? That's the easiest. Please leave Sophia alone. The easiest thing to use is your table. There's a difference between 0 and O. Okay. I'm not there. When she fires you, Sophie is short and powerful. Short people are dangerous. Must know. Where's Lesedi? How? Lesedi? Sedi? Ah, you are in the house. You've been so quiet, my child. What's up? Okay, but you're good. All right. All right, guys, this is what we have. This is how I rule my own table. Might be different from yours in terms of the bars and the columns. This is what I do. Okay, and we have A, B, C. This is why that ratio was important, X, Y, Z. So it's 2, 1, 2. I hope you get that, right? The 2, 1, 2 came from here. That's why if you didn't get that 2, 1, 2, I don't know what you will be doing in this question. Okay. Are we there? Having a glitch in the network now. Just a moment. Can you see my screen? Okay. Work is now misbehaving. All right. Okay. So the 2, 1, 2 is very important, guys. Now, what is the initial number of moles of A? Is 4. Initial number of moles of B is 3. And the initial number of moles of C is 0. So we have 4, 3, 0. I hope that those numbers make sense to you. And now let's look at the final, or at equilibrium. It is 3, 2,5, and 1. 3, 2,5. No. Equilibrium here is 3, 2,5, and 1. I don't know if that makes sense to us. Which means we can get, we don't even need the change because the change we already got. The change here is 1. The change here is 0,5. And the change here is 1, which matches our ratio. Now, what's concentration? Number of moles divided by volume. So this is 3 over 4, which is 0,75. What will this one be? 2,5 over 4, and that is 0,625, I think. And this is 1 over 4, which is 0,25. Now we can write our Kc expression, which everybody should be comfortable to write and to know that we only deal with gases. So all we do is to substitute. What's my A? And what's my B? Please confirm the answer now. The answer now for me. And there is no unit. Everybody okay now? What do you mean, Brown? You were taught something so different. What's up? Yes. Okay, babe, it depends on the question. It was the same question. Okay, but okay, please send it. All right. Kaylee, so confusing, but you're fine now. Let's quickly answer this, then I go look at your request. State the change that was made to the system at 2 minutes and explain the effect of this change with the aid of Leitch-Celius principle. All right, at 2 minutes. Now, what do we notice at 2 minutes? Really, it will have lumed you. Oh, but at least now you can no longer be loomed. All right. Now, guys, the examiner wants us to find out the change that happened. All right, Brown received. I'll check. Now, let's see what change that happened, and then I'll look at your question. Okay, it's a different question, I think. It's a different question, but it's the same principle. Okay. All right, guys, let's answer this one. There is a very sharp increase at A. What do we mean by sharp increase? Look at that. There is a very sharp increase at A. Okay? And A is a reactant. Guys, when you see sharp increase like that, basically understand that you are talking about concentration. That increase is too sharp. Sharp increase. What do I mean by sharp increase? Guys, if you make a cup of tea, all right, that is not sweet already. Go-Go's tea, yeah. Oh, you want to see my table? Okay, I'll show you the table again, Brown. That sharp change quickly talks about concentration. Because 1 spoon of tea, you don't need to wait for it. It changes the concentration immediately. Once you put 1 teaspoon of sugar, concentration immediately changes. So a sharp change is all about concentration. That's number 1. So if you look at A increased, look at B here. B decreased, C increased, A increased, B decreased. Look, guys, let me tell you a secret. Once you have on one side, one going up and one coming down, automatically know that concentration is changing. There's one up, there's one down. Please understand that it's a change in concentration. And the examiner says, explain in terms of Le Chatelier's principle. All right. Concentration of A increases. Forward reaction is favored. Equilibrium shifts to the right. More product is formed. And that's it. That's your 3 marks. I'm sure you all still remember this when we talk about change in concentration. All right. Change in concentration. And that's how you answer such questions. Tamron, here is my table. Now I want to go find... No, I have one more question before I go find your questions. You said 2017 KZN. Yes, Nokuleko? No, right now we are not talking about endothermic and exothermic. We are just looking at concentration. If I was talking about temperature, then I need to talk about endothermic and exothermic. But right now, we're not looking at that. We are looking at concentration. Okay? Mm-hmm. Yeah, Bo. Okay. Oh, people are fighting here. There's Free State and there's KZN. Oh, my God. Okay, let's check this one first. There's one here. Do you want me to do this one? This one has percentage. Or should I go to your Free State? Huh?
chemical equilibrium that has impurity.
Find it and send it to me.
Okay.
All right. Okay. All right. Don't worry, Lionel. I'll do your free state. I'll do your KZN. Okay. But there's just something, I saw this one and I felt, I won't calculate the whole thing, but I just want to show you what to do here. All right. Okay, yes, we're going to look at acid and base, but let me just quickly look at how to do the table in these questions. So guys, all the other theory, I'll leave that to you to deal with. And for this one, I won't do it completely. It's just to set up the table for you, and then you'll be able to deal with the answers. Time is not on our side. All right, an equilibrium reaction for the decomposition of reddish brown is that. Now, it's all gases. Please take note. It's a homogeneous equilibrium. I'm sure you know that because they are all in the same phase. It's homogeneous. Now, quickly, if I were to have my table, please don't write rice, okay? Write it in full. Don't say rice. Examiners are not hungry. Please. Don't say rice so that they can eat and give me marks. It is ratio. Initial number of moles. The change in number of moles. Okay. Equilibrium, number of moles, and concentration. What do we have here? Oxygen, A2O3, and O2. What's my ratio? 4, 2, and 1. Remember, I am just setting up the table. All right. Free state. Okay, that's the same one Lonel was also asking for. Free state 2017. I'll go look for it now. Now, initially, 2 moles. So, initially, these 2 moles comes here. And 1 mole of oxygen. Oh, this is AO2. Initially, 2 moles of A2O3 and 1 mole of oxygen are present in 1 mole per dm cube. 1 mole. All right, I hope that's making sense, guys. All right. Only 10% of AO2 decomposes. It means there was an amount of AO2, but we don't know the amount, X. Is that okay? Now, only 10% decomposed. Oh, what decomposed? 10% is 0,1 of X. That's where the dynamics is. Please take note. They said 10%. We don't know. Let the unknown be X. All right? What is 10% of X? 10 over 100 times what? X. 0,1 X. I hope it makes sense, guys. What are we left with? This is 1X. 1 minus 0,1 would give us what? 0,9X. I don't know if everybody's on board with me. Please let me know if you're on board before I go to the next columns. Everybody on board? All right. Okay, guys, I cannot do all the questions though, but we'll try. Now, what do you notice here? Now your ratios. Do you notice 2 is half of 4? So definitely this one will also be half. 0,1x over 2. You just divide by 2 because it's the half. It must work in ratio. This one is also one of that. Anele, please, can you tell me where you are lost? You and Uncle Leko, quickly, as fast as possible. Time. Where are you lost? Girls, please talk to me as fast as you can. Anele, tell me exactly where you were lost. Exactly, the exact point. I want us to solve it and move forward. Please make it fast time. But Anele, it's there. It's written for you at initially 2 moles. That's the 2. 1 mole. It's there. Only 10% decomposed. It means 10% changed. 10% of X would give you 0,1. That's your 0,1X. Sophie, we're still continuing, right? I hopefully would get there. So that's 0,1X. And all you need to do is to subtract now. And it's just reading and doing maths. All right. You read the question, transfer the information. 0,1 is 10%. From 1, we are left with 0,9. You find 4 to 2 is finding the half. So I divide 0,1x by 2 to get that. Again, 2 to 1. I'm sure you guys were taught how to do ratios. There are so many ways. It's half of that again, and this is 0,1x over 4. Okay. And this could be, there are so many ways. Let's see, what does the examiner want? Use the information above to calculate the equilibrium concentration of each of these species. Okay. All right. Use the equilibrium, use the information to find the equilibrium concentration of this species. All right. So what do we then do? Do we know Kc at all in this question? Let me read blah, 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 blah. Only that, okay, we don't have Kc. So we need to find the equilibrium concentration. All right, this is going to be in terms of X, by the way. Okay? So what are we going to have? This is going to be 2 minus 0,1x over 2. I want to show you something else that might also help you. 1 minus 0,1x over 4. Because some of us are really not good with all of these fractions. So I'm going to go to a fresh page and show you something that might help you where to put that x quickly. Okay. So now I'm running. So it is ratio. Please remember to write it in full. Ratio, initial, change, and equilibrium, number of moles, concentration. What was this? It was A2O3, no, AO2. It was O2. Is that O2? A2O3. Okay, this looks like aluminum oxide. A2O3. And that is oxygen. Okay. And we have our ratio 4:1. So we were told initially 2 moles of this was present, right? And 1 mole. All right, 1 mole of that. And only 10% of AO2 decomposed. 10% of AO2 decomposed. Where is it now? All right, here is it. All right, 10% decomposed. So this was what I said earlier on. We don't know the amount that decomposed. We're given the volume as 1. We don't know the exact amount that decomposed. Is that okay? But that amount is 10%. All right. So it is always easy, okay, to work around variables And that's why I said, let's put x there. What is 10% of x? That would be 0,1x, which leaves us at 0,9x. Now, what is the concentration here? Is 0,9x divided by 1. That's what the examiner. What about here? We divide that ratio by 2, 0,1x over 2. I'm sure we can solve 0,1x over 2. That will be 0,05. Let's make it easy. All right? I hope you understand what I mean. It is 0,1 divided by 2x. So that is 0,05x. So what is this? 2 minus 0, all right? And we divide by 1. That will still give us, please don't say 1 comma something x. These are not like terms. And here we divide that by 2 again. What are we going to have? 0,025x. And what will this be? Because that's also, no, but wait. They said decomposed. Hold on. I missed something. If this one decomposed as a reactant, we should actually be adding here. My bad. All right. 1 plus 0,025. Please take note. Decomposed means it is lost. All right. So with reactants, you minus. And with products, what do? You add. Please take note of that. Reactants, you subtract. Products, you add. Okay. Reactant, you subtract. Product, you add. All right. In this case, we will not be able to solve for x. Why? Because we don't have Kc. All right. We do not have Kc. They said an equilibrium reaction for the decomposition of is that. All right. Only 10% decomposes at equilibrium. We are not given Kc, so we would not be able to get x. If they gave me Kc, then we will formulate our equation and then get our x. All right. So that's what the tone of the question is. So this is what the examiner wants to mark. Okay. Let me quickly check the Kc of this, guys. There is one from Free State 2017. I'm just going to look at it briefly because I need us to get to acid and base. This one is 2014. All right. Guys, I won't be able to look at all your questions. Free State 2017. Then I'll go to KZN. Free State 2017. Huh? Just a second. All right, let me crop this. This is 2017 KZ. No, Free State. I think Leica is the one asking for this. Is it Leica or Loniel? I think it's Loniel. All right, Mduduzi. That's my table. Loniel, why do we add the reactants? Because it's increasing in quantity. Loniel, it is increasing in quantity. That's why it's a plus. With reactants, it is a decrease. Sorted? All right, this is your question. Let's see, guys, quickly. Could this be difficult? Okay, there's X again. All right. Fatima and Rabia, do you see here I have Kc? Okay. Do you see here I have Kc? It means I should be able to calculate this X. Let's read quickly. Consider the reversible reaction below. During the reaction, 4 moles of nitrogen monoxide gas, 4 moles. 2,5 moles of oxygen and X moles of nitrogen dioxide is placed in a 500 cm cube. All right. So this is oxidation here. Let me go and get a table NOO2, 2NO. NOO2 and 2NO. All right. Remember, gases only, right? And aqueous. Nitrogen monoxide, oxygen, and nitrogen dioxide. Ratio, initial number of moles, and what? Equilibrium number of moles. And here, concentration number of moles divided by volume. Set your table before you start calculating. Okay. Now, what is my ratio? 2, 1, 2. Important. 2, 1, 2. We're given this as 4. We're given that as 2,5. And we're given that as X. All right. So I have put all the information that I have so far. Volume is 500 cm cube. So volume is 0,5 dm cube. Remember, we convert. Okay. What else do we have? Let's see. Blah, 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 blah. All right. At equilibrium, there is 3 moles of nitrogen oxide. 3 moles of nitrogen oxide, which is the same as nitrogen monoxide. All right. Nitrogen oxide. And the equilibrium concentration is 0,25. 3 moles of nitrogen oxide at equilibrium. All right. At equilibrium, 3 moles. Now, let's see. Now, this is a reactant. You can actually see that it's decreasing. We start with 4 and end with 3. What is the difference? So, reactant we subtract, right? Oxygen is also a reactant. We are going to subtract. Product, we are going to add. All right, what's the difference here? 1. Okay. When they don't tell you that there is an amount there, all right, when they don't tell you that there's an amount of nitrogen dioxide, then you can consider 0. But this time around, we were told, so it is not 0. So please take note. Good question. All right. How do you work out your ratios? Guys, I don't know how you work out your ratios, but there are different ways. Look, there's a 2 here, there's a 2 here. Automatically copy and paste 1 and 1. This 1 is actually half of that 2. Oh, so here it will be half. There are so many ways. All right, take note of my answers. I'm going to do another method right now for you. There's one method that I usually like, which is called cross multiplication. I cross multiply the ratio and the change. If I don't know this, don't forget it's ratio and change. 2 times A is 2A. 1 times 1, 1. What is A? 1 over 2. So you see again, it's 0,5 there. So whichever method you've been using that works for you, please continue with it. If it's not working, then use the one I just did, cross multiply. Look again, if I cross multiply there, all right? If I cross multiply, let's say that's B. B times 1 is B. 2 times 0,5 is 1, which was the answer I got earlier on. Now let's do the maths. 2 minus 0,5, 2. And this is x plus 1. Can we divide by volume? 3 divided by 0,5, that will be 6. 2 divided by 0,5, that will be 4. And this is x plus 1 divided by 2. That's nothing. No, by 0,5. It remains like that. Now let's write our Kc expression. Now, this is how you do it. So we have our Kc expression. Which one is our product? Nitrogen dioxide. And it's squared over nitrogen monoxide squared oxygen, and then we have that. What's our Kc value again? 0.25. Now, guys, it is just mathematics now. This is what I would advise you to do. If there's only one X, yes?
I think so. Here the question.
Okay, what is the question? So, she's not asking anything. She just says, sir. No, they said nitrogen oxide. It was actually a mistake. They should have written nitrogen monoxide. This one is nitrogen dioxide. Okay? That is nitrogen dioxide.
Yeah.
So when they say nitrogen oxide, yes?
Oh, okay. Okay.
Yeah. It was, I think the M just disappeared. Somebody stole it. All right.
Okay.
So it's nitrogen monoxide. Okay. So what do we have? Guys, you see what I did? I didn't bring it because I know some of you and your fractions are not on the same, you are working in parallel lines. Okay? So I am trying to take out fractions away first. Now, what is my nitrogen monoxide concentration? 6 squared. And then oxygen squared would be what? 4. So what do I know? NO2 squared would be 36 times 4 times that. What is 4,025? That's 1. And 1 times, am I right? 1 times 36 would be 36. Please confirm. Cross multiply. If that's the case, then NO2 would be 6. What is NO2? X plus 1 over 0,5. And I'm sure from here you can solve for X. I hope it makes sense. And that's the question. All right, so you need to find a way to make your math easy. Make math easy for you. All right. I'm going to browse through Mduduzi's question, and then from there I move to acid and base. Mduduzi has a question from where? 27 KZN. Let's go find it. 2017 KZN. Let's check. Prelims KZN 2017. Mduduzi, is it this one?
Yes, sir.
This question is simpler than writing my name. What's challenging here? Why were you seeing flames here?
Sir, I want to confirm my answers, not challenging.
Oh, you should have just asked for a memo. But it's good you brought this on, guys. I'm just going to say something here. Look, we don't work with grams. We work with number of moles. Please take note. If you write 10 grams, you'll be backed wrong. Okay? So number of moles is mass over molar mass. And you need to show that calculation. So 10 grams of hydrogen gas, 355 grams of chlorine gas are heated together in a sealed 500 cm cube container. Okay, please take note, it's grams. You must change to number of moles. So, and this reaction is exothermic. We are given the equilibrium constant as 60, so it means we need to work back up. Calculate the mass of chlorine gas present at equilibrium. Lovely, simple question. I'm going to run through with the speed of light. All right. Let us see. Ratio. Initial number of moles. Change in number of moles. And what do we have here? Equilibrium. Number of moles, and concentration is number of moles. Fill in the table well. Hydrogen, chlorine, and hydrochloric gas. And HCl. What is my ratio? 1:1:2, which makes it easier. 1:1:2. All right. Number of moles. What do we know about hydrogen? 10 grams and 355 grams of chlorine. Please show these calculations. It's very important. Number of moles of hydrogen is mass over molar mass. 10/2, which is what? 5 moles. So I have 5 moles. Initially, again, we have number of moles of chlorine gas, mass over molar mass, 35 over. What is the molar mass of chlorine gas? 71. Am I right?
Yes.
71. So what is 355 divided by 71? That's 5. 5 moles again. All right, let's go and check. Please don't assume that it's 0. Let's go. It says 10 grams and 355 grams are heated together in a seal. Now, do you see this time around, they didn't tell us that there was hydrochloric acid there. That means it was not present. That's when you can write a 0. Okay? Now, again, what do we know? Volume is 0,5. We're told to calculate the mass of chlorine gas present at equilibrium. The mass of chlorine gas present at equilibrium. But we were told that Kc is 60. We're looking for the mass present at equilibrium, the mass of chlorine gas. They said, you know what I will do? I will write X there. Present at equilibrium, because we didn't know it. But Kc is 60. All right, will that be okay? Can we work with that? All right, it depends on you though. We can put the X anywhere. It depends on you. Okay, if I put the X here, this will be 5 minus X. By the way, my volume is what? 0,5. I hope it's making sense. 5 minus X. This one will also be 5 minus X. Now, it might look a bit complex here. All right? Might look a bit complex. Once you see that this might look complex, I'll get the same answer. But let's say, what if I put my X here? So you need to be creative based on how you see your maths. If I put X here, because I don't know the change, this one will also be X because of this ratio. 1, 1. Now, this is 2. It's double. That will be 2X. This might be easier. Okay. Now, reactant, product. 5 minus X, 5 minus X, 2X. I hope it's making sense. Now, this is 5 minus X over 0,5. 5 minus X. Okay, I'm actually going to finish this question. And this is what? 2X over 0,5. I'm sure we can divide 2 by 0,5. We can get an answer. That is 4. Confirm for me. 4X.
Yes, 4.
Okay, 4X. Now, please look at the mathematics here that I want you to learn. Remember, please don't do this on a rough page. It's part of the solutions. There's marks for that. Now, let's go write our Kc expression. Yeah, somebody calling? Kc expression. It is HCl. And I think there's a 2 there. Hydrogen gas, which is 1. Chlorine gas, which is also 1. 60 equals to. Now, do you notice all of them have X? So I don't have a choice. HCl is 4X all squared over, watch the math I'm going to do here. 0, it's 5 minus X over 0,5. I hope you're still following. 5 minus x over 0, 5. 5 minus x over 0. Please don't expand. That is the maths. Thank you, Mduduzi, for this question. Don't expand. Look at what I'm going to do. Somebody's saying, but what are we going to do if we don't expand? 60 equals to 16x. Okay, no. 4x, leave it as squared. Over 5 minus x over 0, 5 all squared. Let's use our algebra, guys. A squared over b squared can be written as a over b all squared. Take note of that. All right. Now, don't expand. A squared over b squared mathematically. So that means I can write this as 60 equals to 4x over 5 minus x over 0, 5, right? All what? Squared. Do you see? I can now find the square root of both sides. What is the square root of 60? Root 60 would be equal to what? 4x. Now check what I'm going to do, guys. This is divided by, let's simplify the maths, over 0, 5. I want us to work, in simplified form. All right, 2 root 15. Okay, I'm going to get there now. Root 60 or 2 root 15. We are still going to work around it in decimal. All right, 4x times 0, 5. I'm sure you know this maths, right? Now we can simplify. Look, chemistry is done. This examiner is just testing maths now. 2 root 15. 4 times 0, 5 would be 0, 8x over 5 minus x. I'm sure we can now cross multiply. All right. This will be 10 root 15 minus, it depends on you though. 10 root 15. Yes?
4 times 0, 5 is not 0, 8. It's
2.
Oh, sorry, 2. Okay, at least you're following, you're not sleeping. 2x. Okay, now from here, guys, it really depends on how you want to work around your mathematics. Please don't cancel. Please. All right. So I cross multiply. 2 times 5 will give me 10 root 15 minus 2x root 15 equals to 2x. I think now we can put all our x's in one house. We can put them together. 10 root 15 would be 2x plus 2x root 15. Or if you want to keep it as root 60, or if you want to change it to decimal, for me, I just want to get the correct answer, so I leave it as that. All right, 10 root 15. But there's nothing wrong with you using decimal. X is common. 2 plus 2 root 15. What is x? We divide. All right, we divide. 10 root 15 divided by 2 plus 2. I'm trying to do this to avoid me rounding off. I don't want to be tempted. What is x? 3 comma? But this is moles. But the question says find the mass. Now we know number of moles is mass over molar mass. What are we looking for? Mass chlorine gas. That means I need to multiply this by 71. Mass.
No, sir. So I think you don't have because they want it. So please go.
What are we looking for?
The equilibrium with 5 subtract x.
Let me go back to the question. Okay, wait. Calculate the mass of chlorine gas present, all right, at equilibrium. All right, at equilibrium, 5 minus x.
1.03.
What is 5 minus, so at equilibrium, what do we have? 5 minus 3,97, 1,03 moles. All right. And from there, you can calculate your mass by multiplying by what? 71, I think. What's your answer here? 73,13 grams. And that's your answer. 10 marks. All right, guys. I hope you see the dynamics there. Especially the maths. But I hope it makes sense. I hope it makes sense. It's a KC question, but they want you to do the maths. So, guys, please try as much as possible not to expand. Expanding would lead you to factorization. And when you factorize, you start having issues. Okay. I hope it makes sense, guys. Applause. Introduce, you have your 10. Okay. Beautiful. Awesome. All right. You can find as many other questions to do. Let's come to this acid and base. I want to believe that for acid and base, guys, what we should be challenged with, or what we are challenged with, will be the main calculations. I know the 7 marks. Am I right? Sophie? Here is your acid and base. Quickly tell me what's your challenge, everyone. 30 seconds. Am I right to say it's the calculations that are challenging?
Yes, sir, the calculations. So when given a pH equal to 0, how am I supposed to calculate the number of moles of concentration somehow?
Use the formula.
When pH is equal to 0, use the formula. How?
Ask this. The concentration will be 1.
The concentration will be 1?
All right. So pH, let me just give you, pH is equal to negative log concentration of hydronium ions, right? Now, the concentration of hydronium ions will be equal to 10 to the power of your pH. All right? So if your pH was 0, what's 10 to the power 0? 1. Nonku?
Thank you, sir. Okay.
I think it's negative pH, yeah. Negative pH. Because we have to negative pH. Okay. All right, guys, let's just quickly look at the last calculations. I think that's where the challenge that we might be having would be. So, I'm going to go straight to 7.3. All these definitions, you should know them by now. The learner, please, let's read carefully. The learner adds 25 cm cube of sodium hydrogen carbonate with a concentration of 0,1. I beg you, please, read carefully. There's a lot of concentration and number of moles here. The learner adds 25 cm cube. And the concentration is 0,1 moles per dm cube to an Erlenmeyer flask. This solution is now titrated with, do you see there's too many concentrations here? 0,1 moles per dm cube. all right, from a burette. Listen, in order to reach the end point of the titration, end point, the learner, before we go to end point, before we start, NA over NB, once you see end point or complete neutralization, that's what I'm going to be working with. End point or neutralization. Now, it says, in order to reach the end point of the titration, the learner needs to add 12,5 cm cube. Oh, so here is 12,5. Are we okay? So that should give me a complete neutralization. But let's check what this learner did. During the titration, the learner accidentally exceeds the end point by adding an additional 4. I love this. Now, please, if you have been distracted before, please don't be distracted. I'm going to ask you to give me 40 minutes to deal with acid and base with you. 40. Hoping to finish at 5:30. So that you can also have time to rest and go over. No matter how much I do, it is what you really do that puts the cherry on the cake. Okay. All right. Now, it says, calculate. This is how I do mine. Memos will confuse you and not tell you where to start from. Let me help you diffuse that memo now. It says, calculate the pH. This is where I start from, guys. I go first and write the formula of pH. Examiner says, calculate pH. Because nobody's going to tell you where to start from. Okay, so let's see. pH is equal to negative log hydronium ion concentration. This is me doing my mind map for English now. Wait. For me to get pH, I need that. Wait, what is that? That is concentration, which is number of moles divided by volume. I've not even started. I'm showing you how to know where to start from. All right. Number of moles and volume. If I can get these ones, then I can bring it there and I can get my pH. Let's go work with number of moles and volume. Wait. There is something that they mentioned here. Exceeds. It means that we have excess. Oh. So the pH, I'm going to say a statement. Let me know if you are okay. The pH of the final solution, this statement, if you are okay with it, let me know, is determined by the active, which is excess number of moles in the final solution. Please let me know if it makes sense to you. What determines the pH is the number of moles in the final. Remember, the question says pH of the final solution. So what determines that is the number of moles here. This number of moles is what will determine the pH. I need your response on that statement. What determines the pH is the number of moles that is remaining. Talk to me, people. I only have one response. What determines the pH is the number of moles that is active. All right, thank you. So for those of you that are lost somewhere, I don't see anyone yet. You should be able to, come on, Loniel. I think her network is disturbing her. She logs out and logs in again. Come on, network, behave. All right. So the whole idea is, now I know where to start from. Let's go and find number of moles of the excess. Then we can find the total volume. Once we get that, we get the concentration. Game over. Your 7 marks is in the bag. So this is what we have. So, what do we have? We have 25 cm cube of sodium hydrogen carbonate. All right? Mind you, don't forget, it is 25 cm cube of sodium hydrogen carbonate of 0.1 moles per dm cube. We are told that this should be neutralized by 12.5 cm cube of, what acid are we using? Sulfuric acid? Yes, 12.5 cm cube of sulfuric acid. This is complete neutralization. That's what the examiner told us. Neutralization. But this learner mistakenly added, please check, an additional 4. The examiner should have told us this learner added 16.5. This examiner is nice. To have a complete neutralization, we need 12.5. So if this learner had said that they added 16, it means 4 was extra. 4 moles, 4 cm cube of H2SO4. This is extra. That is what we are going to deal with. Now watch this. The concentration of the final solution, which is number of moles divided by volume. Look at what I'm going to do. We added 4 cm cube. That's excess that we don't need. The question is, what is the number of moles that we have added? So I'm going to start by saying, let's calculate number of moles there. All right? Of excess sulfuric what? Acid. Do we know the concentration? 0.1. We don't know the number of moles. What is the volume? 0.004. I hope you understand what I did. So what is the number of moles of sulfuric acid in excess? 0.0004 moles. Everybody okay with that step?
Yes, sir.
Nonkululeko, where are you lost? Is she here? Yeah. Talk to me quickly. I want to tell me exactly where you are lost. It's easy for me to find you.
I don't understand the quadruple method.
But that's the additional one. Go back to the question. Did you see the question?
That's the problem. The question is on another slide.
No. Read the question, Nana.
Yeah, I can see now.
Okay. So the learner accidentally paused extra. What volume was the extra? It was 4.
Oh, okay.
That's the one that is excess now. That's why I have to look for the number of moles of what is excess.
Okay, sir.
All right. Guys, I hope my calculations are okay. Just keep checking with your calculator. 4 divided by 1,000, 0.004. Am I right there? And multiplied by 0.1, 0.0004. Okay. Now, I have the number of moles that is in excess. Let's go calculate concentration. So concentration of excess or final solution, let me say final solution, number of moles divided by volume. What is my number of moles? 0,004. Guys, what is the volume? I want to hear you. What is the volume? What is the volume? What is the volume? I have a 0,1. This is where the key is now. What is the volume? We said concentration is number of moles divided by volume. We are looking for the concentration of the final. Once we get this, we'll be able to get our pH. That's what we're saying. Let's say this says 41,5. Guys, please look at this statement. What did I write here? Because we are looking for the pH of the final solution. What is the volume of the final solution? Let's say this says 41, the data says 0,375. Final solution. Guys, I started by pouring 25. Then I poured 12,5. Now I added 4. That's your final solution. The addition of the 3. We are talking about final. So how many things did we add inside? We added 3 different volumes. 25 plus 12,5 plus 4. So that is 16,5 plus 25. That is 41,5. I hope it makes sense. Volume of the final. Guys, always read the question. The question would always be the guide. Calculate the pH of the what? Solution in the flask. After. All right. So now we got 41. That's the total volume, which must be divided by 1,000. So what's our answer? We must always divide that. 41,5 would give us what? 0,0415. Am I right?
Yes, sir.
Yes.
Okay. Now, what is the concentration? Give me an answer. I hope it makes sense, guys. It's about step-by-step approach. What is my final answer? What is the concentration? Anybody with an answer yet? 0,00. Please be careful of the zero. 0,04. Use your calculator to confirm all the time. Don't do like me. 9,638 or 9,6. I don't want to round off so early. So 9,638. 639, at least 3 decimal places first. 639 times 10 to the power negative 3. Moles per dm cube. Of which acid? It is H2SO4 that is excess. All right. Now, how do I get my pH? Negative log. I don't know if you guys were taught, but those of you that I taught acid and base, you know that this is a diprotic acid, which means I've got to come here and say 2 times 9,639. All right, so on your calculator, you can press negative log 2 multiplied by answer. and you get me the final answer. What's your answer? I have a 1,71. Is that what you all got? And it makes sense because it's acidic. It is the acid that was excess. That's why it is acidic. Please give me your feedback. Are you okay with what I did? The first thing, guys, is don't jump into calculating. No. Draw out a mind map. Examiner says calculate pH. Write down the formula first. pH equals to that. What do I need to get pH? Oh, I need number of moles. Number of moles of what? Which one is active? Number of moles of the excess one. This examiner is actually nice because sometimes you have to subtract a few things before you get that 0,004. You've got to do a few subtraction and additions before you get that 0,004. This one came very handy. Let's see. I should have another acid and base question. Let's go find it. KC. I think there's one somewhere. Hiding somewhere. Hiding. KC. Acid and base. Okay. Let's hit this one. Let's see. Is there anyone with a question, acid and base question, that you really need us to do? I would rather do yours than do this one that is here already. Or I can look at that. Just one from someone. After we finish this one. Yes.
Question 7 of the free state paper 2014.
2014 free state. It's showing you flames.
I just want us to do that together.
Aww. Do it together as one house. Free State 2014 paper 2, right? Okay. Which one is it now? Let me close all of this. It's like... all right. Question 7. This one, Nonkuleko?
Yes, sir.
Oh, I see a pH of 0. That's what's confusing you. Okay, so, guys, I know you know conjugate and all of those. I'm just going to focus on 7.2, right? Deal? Guys, deal?
Sir?
I'm just going to focus on the 7.2, the calculation. All the other one, anpholides, conjugates, we should be comfortable with all of those. All right. Let's quickly check. All right, deal. Thank you very much. A learner adds an impure sample of sodium carbonate into a flask containing 50 cm³ of hydrochloric acid solution with a pH of 0. That's where my nonku got lost. pH of 0. All right. The hydrochloric acid is in excess. Take note of that statement. The hydrochloric acid. So the first thing is that pH, no, the first thing is it is impure. Second thing, pH of 0. And the hydrochloric acid is in excess. The balanced equation for the reaction is given as that. All right. First one, calculate the number of moles of hydrochloric acid present in the flask. Let's go back again. The learner adds an impure sample, which we don't know, into a flask containing what? 50 cm³. So we know the volume of HCl as what? 0.05 dm cube. Please don't make a mistake, always convert. We are told that the pH equals to 0. Life is easy. We want number of moles. Please always start from what they ask you to calculate. It's always easy. Number of moles is CV. I'm sure you all know where I got that formula from. But I do not have concentration. Wait. pH is negative log that. And I gave you a formula a while ago. All right. Concentration of hydronium ion is actually 10 to the power negative pH. Please know that formula as well. So in this case, what is the concentration here? 10 to the power negative 0. Do you want to give me an answer here? Let me check your maths. There's nothing like negative 0, right? So the answer is 1. Nonkuleko, do you see what I said earlier on? 1. So number of moles is concentration 1 times volume. So what is that? 0.05 moles. 5 marks. 5 marks. Easy. Write down a balanced equation that explains why sodium carbonate solution has a pH greater than 7. That is actually hydrolysis. Hydrolysis. You're welcome, Nana. Tandiswa, I saw your question. I'll answer you. Hydrolysis of sodium what? Carbonate. Let's see. Why should it have a pH greater than 7? Hydrolysis means there must be water involved, and it's a reversible reaction. Look, the first thing here is to break this down. Na plus. Okay? O2 and CO2. Now, break this down as well. H plus and OH minus. Oh, it has a pH greater than 7, which means it's a base. It is actually, we're actually going to produce OH minus. All right. We are going to produce OH minus. So if we hydrolyze this, what are we going to have? So this is the key thing. This is where the mark is. Because it's a base, it's going to produce more than, it's going to produce a pH greater than what? 7. All right, so the rest is just history now. Okay. The rest is history. What are we going to have? We're going to have Na, all right? That is positive. Okay? It's an ion, so it's going to remain in the solution. We're talking about ionic solutions here. Okay? Basically, if I want to use ionic equations to explain this to you, I would have said my sodium would be Na plus and CO3 2 minus. Okay, which is that? That's my CO3 there, 2 minus. Okay, and when that then reacts, remember I have H plus and I have what? OH minus. You can actually do an ion exchange, and that would give me Na plus OH minus. That's my ion exchange. Plus what? HCO3. I'm writing everything as ions, and you are allowed to do just that. Why will the pH be greater than 7? The pH is greater than 7 because it produces hydroxide ions. Remember, it is a base. You must be able to define your acid and your base. It is very important. A base is a substance that does what? Produces hydroxide ions when ionized in water. Some people would use the word dissociate. It's actually the same thing. Both are changing to ions at our level. All right. So that is how it will produce hydroxide ions. And since it produces hydroxide ions, it means it has a pH greater than 7. Everybody okay there? Everybody okay? Talk to me. Let's go get some 6 marks now. Let's go get them 6 marks. Awesome. The apparatus illustrated below is used during the titration to determine the mass of sodium carbonate present in the sample. Percentage purity somewhere there. What is the name of A? Can somebody tell me the name of A? What is the name of A? It's a burette. Thank you. Thank you. All right, guys, at least 1 mark there. Now, 7.2.4. During the titration, the excess hydrochloric acid is neutralized. Watch this. There's a keyword I'm looking for here. The excess hydrochloric acid is neutralized by 30 cm cube of 0.4 moles per dm cube sodium hydroxide. Calculate the mass. Wait, let's follow the sequence. The excess hydrochloric acid. You know the problem here is, guys, I don't even know the excess hydrochloric acid. Here is the 411 of acid and base calculation. Junisani and Duduzi would be happy now that I'm saying 411. If you have 2 reactions, A and B, look, I can tell you that in 98% of the case, start with reaction B. Start with the second one. Okay. Start with the second one. Let's go write our first reaction and our second reaction. 15 minutes or 13 minutes, we should be done. Now, our first reaction was sodium carbonate plus hydrochloric acid, right? So we have sodium carbonate plus hydrochloric acid. That gave us sodium chloride plus carbon dioxide plus water. All right. Is this balanced? No, there's a 2 there. Now, our second reaction, look at our second reaction. Our second reaction was the reaction between hydrochloric acid and sodium hydroxide. They expect you to know that. That's why they didn't give you sodium hydroxide and hydrochloric acid. That will give us salt and water again. Now, let's go write the information that we have. This is the key. They said the excess hydrochloric acid, which we don't know, because we don't even know what was used in the first one. All right? So I don't know the volume here. All right? I don't know the volume here. But wait. Am I given information about my sodium hydroxide? Yes, 30 cm cube and 0.4 moles. Done. We are done. Volume is 0.03. Concentration is 0.4. And they told us it neutralizes. Watch this. It neutralizes. What is the concentration of our HCl? 1 mole per dm cube. Awesome. Now, check this, guys. 1 mole. Because the examiner said neutralizes, you know what formula I'm going to use, right? I think I mentioned that a while ago. When they say neutralize, what am I using? Na over NB equals to what? CAVA over CBVB. Do I know the number of moles of acid? 1. Number of moles of base? 1. Oh, 1 over 1. Concentration of the acid? 1. Volume of the acid? Unknown. Concentration of the base? 0,4. Volume of the base? 0,03. Check my calculation for me. I should have 0,012 dm cube. Please check. Am I okay? Am I correct? Am I correct?
Yes, sir.
All right. Now, what did we calculate? It is the volume of the excess HCl, which was used in reaction 2. Now, what is the volume of the original HCl that we have? Do you remember we were given? Don't forget information. We were given that. They said what? A learner adds an impure sample of sodium carbonate into a flask containing what? 50. Out of that 50, which is 0,05, we have used 0,012. All right. So it means the volume of HCl used, please let me know if this is okay, used in reaction 1 is 0,05 minus 0,012. Please talk to me. 0,038 dm cube. Please talk to me. Do you understand what I just did? The total volume was 50. We used 12 in one reaction. What did we use in the other one? 38. Because together it must give us 50. All right. Good. Now we can go back to reaction number 1. Sodium carbonate plus HCl. Let's go check. Sodium carbonate. I'm finishing. Sodium carbonate. It's been a long day, but I'm sure the session has been helpful, guys. The 2 sessions that we had. What do we have? Volume is 0,038. Concentration is 1. Only pure substances react. Take note of that. Only pure substances react. So there's a reaction here, and I don't know the number of moles. But I can get the number of moles of HCl. I'm going to tell you something right now, guys, when I finish this. All right? What is the concentration? 1. What is the volume? 0,038. So the number of moles of HCl is, I'm going to make this clear because some of you just think, oh, this guy is just going on. I don't even understand what he's doing. I'm going to make this clear. Now, mole ratio. 1:2. Acid and base. There's something about that topic that just tickles me, you know. I don't know, but there's something about it that just excites me. N. What's the number of moles here? 0,038. Can I calculate number of moles then? 2N equals to cross multiply. Right? So the number of moles is 0,019. Oh, number of moles is mass over molar mass. 0.19 is mass. What is the molar mass of Na2O3? I'm sure you guys can do the maths later. 23 times 2 plus carbon is 12. Oxygen is 16 times 3. You can then get your mass. I quickly want to give you the total summary of calculations of acid and base. Please listen to this. examiners will require something from you. So they'll require something from you. That something has to do with number of moles. So in most cases, it could be mass. So they require mass from you. So they require the mass. Don't let me say something now. They require mass of A from you. For you to get the mass of A, okay, I'll help you. For you to get the mass of A, check this. I need to get number of moles of A first. So I need the number of moles of A. This is the sad part. You will not be given the number of moles of A. This is the happy part. They'll give you a way. You will be given a way to get the number of moles of B. So this is your what you do. Find number of moles of B. Use mole ratio to get the number of moles of A. And then you can calculate the mass of A. That is the dynamics. They will not give you number of moles of what you are looking for, but they'll give you the number of moles of another compound, and that you will then use mole ratio. This is what I mean by mole ratio. So you would see, check this. We needed the number of moles of Na2CO3, but they didn't give us. We had to calculate number of moles of HCl first, mole ratio, then we got the number of moles of B, and then we got our answer. I hope it makes sense. I have just 3 minutes, and I want to answer 2 questions that they said the people are asking. All right, one was, how do you calculate percentage purity? And the second one is an explanation on ampholytes. Non-clerical. Percentage purity is the mass of pure substance over total sample of impure multiplied by 100. And percentage purity plus percentage impurity should be equal to 100%. Now, in this example that we did, what's your answer here, guys? Give me your answer here. I want to just add something to it. What's your answer here? I want to show you percentage purity from here. Somebody who got this answer? We're finishing now, guys. Somebody who did the calculation? (2,014). All right. Now, non-kuleko. This examiner could have phrased this question this way, which I'm going to change. I have powers to do that. A learner adds an impure sample. Look at what they could have done. A learner adds 3 grams of impure sample. You see what I've done? I have simply added my grams, the total sample. Now the question would be, calculate the percentage purity. You will do exactly what I have done here. And now we have the mass of the pure substance. What is the mass of pure substance? 2. So what is my percentage purity? So only 2,014 is pure out of 3. Oh, so what is my percentage purity therefore? 2,014 over 3 multiplied by what? 100. And this will have been about 70% or 68%. You can check. But 67%. Somewhere there, 66.7. Am I right? Oh, 67.13. All right, close. So 67.13% pure. It means if you are looking for impurities, you subtract that from 100. So here's your formula. Mass of pure. Don't forget, only pure substances react. So whatever calculation you're doing using mole ratio and all of that, you are simply looking for the mass of pure substance. Uncle Echo, are you okay? And finally, all right. And finally, Tandiswa said, I don't understand ampholyte. It's very simple. Ampholyte are substances that act as acids and a base. And it is very easy. I know that all of you know example. Example that you know. What's the example? Water. What are the other examples? Derivatives. Okay, please don't derive. All right? Derivatives of polyprotic acids. I'm sure you know what polyprotic acids are. Polyprotic acids. You still remember what polyprotic acids are? Acid that can donate more than one proton. So this is what I will do. Give me an example. H2SO4. It's a very simple dynamics that I use here. If we take out one proton, what are we going to have? HSO4 minus. If we take out another proton, what are we going to have? SO4 2 minus. The one in the middle is an ampholyte. That's another example of an ampholyte. I'll give you another example. Carbonic acid, H2CO3. Take out one proton, HCO3 minus. Take out another proton, CO3 2 minus. The one in the middle is an ampholyte. I'll give you another example. H3PO4. Take out one proton, H2PO4 minus. Take out another proton, HPO4 2 minus. Take out another proton, PO4 3 2 minus. The ones in the middle are ampholytes. All right. Those are examples of ampholytes. Something that can donate and something that can accept a proton. Okay, guys. I think it's been all good. It's been all good. Are we okay? Are you happy with the session? Did you get some things clear? Give me a quick feedback. I'd love to read from you. I'd love to read from you. Oluetu. I'd love to read from you.